Hello friends, so far we have seen node embedding. Now let's look at edge embedding. Now the first question we should ask ourselves that when the edge embedding is needed. Let's look at the edge level task which may have to perform during our analysis of biological networks. So here I have given set of diseases for different organs, and typically diseases are complex in nature and many factors plays role to exhibit diseases, and these factors can be at genetic level or at metabolic levels or protein-protein interaction levels. And typically proteins are the one which are actually targeted to get a cure or some kind of treatment for particular disease. And these particular proteins do not work in isolation, and they work together. A set of proteins interact with each other in a different diseases to modulate complete molecular machineries to exhibit either disease or non-disease conditions. And some kind of malregulations in these protein-protein interactions can create diseases. And here, what we are trying to see is that there is possibility that particular protein malfunction can create certain disease in certain organs. For example, if I know that the malfunction of the protein number 1 here, protein number 2, protein number 3, protein number 4 and protein number 5 can create certain diseases in a certain organ. For example, some protein here can create disease in this particular case. So I know this particular link, and this same kind of protein level interactions or malfunctioning can cause protein in a kidney and etc. However, I do not know whether this particular protein 4 can be interacting with some other protein in creating a certain disease in this particular organ, or this particular protein can create a disease in this particular organ. Similarly, if I look at the drugs, so certain, as I mentioned earlier, drugs are small molecules that inhibit proteins and try to cure or treat disease. Now, certain drugs are available to inhibit certain proteins. However, we do not know certain drugs which are available in the market which are used for protein number 2 can be also used for protein number 5 to inhibit that particular protein. Now, if we look at this particular phenomena or process, if I generate a graph with each of these disease related, organ related disease, or I generally call disease in that particular organ as a node, protein as a node, and the available interaction between this protein and disease as an edge. And similarly, if I create a set of drugs which are available, molecule as a node, and the available drugs and their protein target as edge, or these interactions, I'll call it as a edge, then the question I'm asking is that can I predict more interactions which allows me to understand a process better? For example, is protein number 4 plays any role in a disease related to lungs, or protein number 3 can play any role in disease related to heart. And similarly, particular this kind of drug which can inhibit certain protein, can it actually also inhibit another level of proteins? So in a drug discovery process, I would like to create a set of edges to find out what are the possible drugs and the protein targets from the available data about protein interactions in a particular disease and drug target in a drug protein interaction databases. So here the link prediction target is nothing but an edge level task where we are trying to predict, is there any link between two nodes or not? Okay. This is what I am trying to see. The question mark indicates, is there any link between this protein and this drug? And that's what we are going to look at in the next couple of slides, where how we can actually use some of the ideas we have used for node embedding can we extend to edge embedding, and how. So let's look at the problem of edge embedding. Now, if I look at this problem, I can see that I am looking at some kind of embedding for this edge, this edge, this edge, this edge, or this edge. Okay. In other way around, if I look at this edge is typically represented by interaction between U and X, or U and V, or V or W, X, W, and X, V. So for each edge, there are two nodes are playing roles. So can we ask that this particular graph, I can look at it as an embedding of edge is nothing but is embedding of pair of nodes. And if I do this way, then I can create a representation for each edge here through our knowledge of embedding of nodes. So again, what we are trying to do is we are trying to look at a pair of nodes instead of a single node which we have looked at it during our node embedding. The task here is simple. We want to generate embedding for each pair of nodes or for an edge. For example, if I look at the creating an embedding for this particular edge, in other way I can look at is, can I create embedding for node pair X and W. So the task of embedding of edge can we look at it generating embedding for each pair of nodes based on some operator G which takes these two nodes and provides an embedding for Z, U, V, or for particular edge connecting U and V nodes. So let's discuss how we can do that. So what is this operator? Now look at this operator G or function G. So edge embedding operator G can be looked at as something similar to what we have looked at for decoders. So let's take a set of nodes, two nodes U and V in node set V, and we have already defined ZU through our encoder function F, which gives you embedding for node U. Similarly, we can get embedding for node V using our encoder function on node V. Now for each pair of nodes U and V, we can define an edge representation, which is our operator G, which is going to operate on both node U and V, is as a function which moves from V cross V, which is all pair of nodes, which is technically edge set, but this function will operate on all the nodes and creates an embedding in R dash, which is embedding vector, which is D dash dimension. Here we are considering D dash, which is different from D. It can be equal to D or it can be different, which is the embedding vector size for edge. So it's the edge embedding vector size or representation of edge embedding, which actually is computed using operator G. And as I told you, this V cross V is not edge set because we are defining embedding or putting operator G, applying operator G on all pairs of nodes irrespective of whether they have a connection or not. Now the question is, what are the form of G? So here, the operator for nodes of pair can be average, which is G ZUI plus ZVI by 2. So sometime you can think of G as f of encoder of U and encoder of V. And this G here is just some average of each element of U and V divided by 2. So similarly, we can define Hadamard operator, which actually take element-wise product, weighted L1 or weighted L2 norms. So, okay, here we have a weighted L2 norm square. So here we are taking it as a square of each element in L2 norms. So these are different operators we can use. G is defined on each node pairs, and the FINC is the encoder embedding.